Hello.
Hola,
Hi.
Hi. We're really excited for today's lesson. This is actually day 2 of a 2-day project. So if you have not seen day 1, I advise that you do that first, or this won't really make much sense to you. So yesterday we introduced a project of creating mosaics on the sidewalk using our geometry knowledge. So today we're going to learn a few new terms. We're learning about measuring angles and all sorts of things. But we're also going to get a chance to look at Madonna and Karosh's mosaic outlines, and Danielle, she did this too. So we're going to get to see how close they are to our key. If they followed instructions exactly, then theirs should look pretty much nearly just like mine, right? And Madonna made her own. She made a custom one. So we're excited to check that out too. So before we get to check out their mosaics, let's go ahead and dive into the vocabulary words for today. Karosh, did you have a question?
Yes, I just wanted to add something. So we were last time said we were going to be going outside to do this whole thing, but instead we had some technical difficulties, like screens got canceled, Manna couldn't connect, all kinds of things. There were audio issues, we had to use our phones, whatnot. So yeah, we're just going to be doing this inside, and we drew ones on paper. Yeah.
Yes, good point. Thank you for telling us that. Yeah, we had to modify it for sure. And if you're doing this at home and you don't have access to chalk and stuff, Karosh mentioned yesterday, but you can follow the instructions and just use inches instead. So Danielle has an example, and I know
Yeah, that's what we ended up doing. Instead of 5 feet, we used 5 inches.
Yep, exactly. So Karosh did that as well. So we can kind of check out our smaller scale models as well. So let's dive into that vocabulary. Our very first word is actually for Karosh. It is angles. What is an angle, Karosh?
An angle is just the point where two lines meet. So if this is a line and this is a line, the angle is right here at the tip of the two lines meeting. So it'd be right here, yeah, or at Mandy's elbow, right here. So that is an angle. Like this would be a 90-degree angle, 45-degree, 180-degree, or if it went all the way around like this, that'd be 360 degrees.
Nice. Thank you for that. The next one is obtuse angle. And that's Madonna. You're muted.
I always do this.
Okay.
An obtuse angle is so an angle that's bigger than a 90-degree angle. So I have my 90-degree angle right here, and an obtuse angle would be something bigger than the 90-degree angle. So it looks something like that. So you see the differences in size, and if you somehow can't see the differences in sizes, I could just put what I did to that one on the 90-degree. So you would obviously now be able to see the difference in sizes. So you know an obtuse angle is bigger because it's more than 90 degrees, which is a 90-degree angle, also known as a right angle. So that's how you know it's an obtuse angle.
Very good, Madonna. The next one is acute. Karosh has that one for us.
An acute angle is any angle smaller than 90 degrees. So if an obtuse angle is any bigger, an acute angle is everything smaller than 90 degrees. All of these, 1 degree, 2 degree, 3 degree, 4 degree, 5 degree, 6 degree, 7 degree, 8 degree, 90, all the way to 90. Or actually not 90, all the way to 89.
Nice. True. You're exactly right. All the way to 89, right? Because if we have 90, that's a right angle. Yep. Good work. Nice job, Karosh. You're exactly right. The next word is actually the measurement tool that we use to measure angles, and that is called a protractor. And Madonna has an example of that. She has one with her right now. Can you show us your protractor, please?
So yeah, this is what a protractor looks like. It's so it's supposed to help you measure your angles and know what degrees they are.
Exactly. So in this case, can you hold it there for a little bit?
Yeah.
Okay, so when we were talking yesterday, we went over the term vertex. So a vertex is where the angle comes to a point, right? So the vertex here is actually where my elbow meets my fingertips. Okay, that's the vertex. We want to put that vertex in the very center of that protractor where it looks like kind of a cross. Yep, exactly there. Yep, exactly there. That's where we're going to put the vertex, right? So you can't really tell on Madonna's protractor, but on the bottom part of her protractor, there's smaller numbers from left to right, okay? And it's the opposite on the top, okay? There's a reason for that. When you are measuring using a protractor, you always have to ask yourself this question. Is the angle obtuse or is the angle acute? So we know an acute angle is below 90 degrees, and we know an obtuse angle is greater than 90 degrees. So when you're measuring your angles, you're gonna see two numbers at the same point. You have to say, okay, if this number is greater than 90 and it's an obtuse angle, then it must be the larger number, okay? So that's the tricky thing about protractors, is because your angle is gonna show two numbers, okay? So let's say that this is my example and I measure it with my protractor and I see the numbers 45 and 145, okay? So if that's the case, what would the actual number be?
Well, the actual number, because it's an acute angle, would be 45. Because acute angle is always something lower than 90 degrees, right? So it would be 45 and not 145, because obviously 145 is bigger than 90.
Great, exactly. So that's just something to check your answer. If you get a larger number than 90 degrees, but your angle looks like it's acute, then you must have chosen the wrong number, right? So that's one thing to remember when using your protractor. All right, thank you, Mandana. You can go ahead and put it away. Thank you for that. All right, so if Danielle would please share with us our mosaics, I'm really excited to see how close you guys were to the key. All right, so we took pictures of the sidewalk as well as pictures of the small scale ones that Danielle drew. So the key is in the top left here in blue. So that's the one that I created when I created the instructions. So we want to see how close we were. Karosh, can you tell us a little bit about your mosaic?
Yes, so as you can see, I missed the key by a lot, and the reasoning is because I had see the giant diagonal line going from the bottom left of her drawing to the top right of her drawing. Well, I accidentally, yeah, you can go over it, had done mine from the bottom right to the top left. So it messed everything else up, because then I had to like put the lines on the wrong side because of it. And yeah, it messed it up because of that. But if that was really my only mistake, yeah, that's my mosaic, but I did it better on the 5 by 5 inch.
Nice. So he did both. He did sidewalk mosaic, that was large scale, so he used feet as his unit of measurement, and he did the small scale one and just used inches as his unit of measurement. And Karosh, you did a really nice job. It was not easy to follow the directions. In fact, Danielle did it as well, and she did it a couple times to get it exactly the same as mine. So it could have been an error in instructions as well. So I think you did an awesome job. And you can tell that you've got your equilateral triangle in the bottom right, just like you should. And you've got parallel lines like you should. So you followed directions very well. Let's go ahead and scroll down. Let's take a look at both Danielle's and Mandana's. Nice. So there's Danielle's, her paper drawn mosaic. It's perfect. She did it just right. So she followed directions really well. And then Mandana, she did a custom mosaic. So she did her very own. She made up her own rules on this, which I love.
And that wasn't really purposeful. So I didn't realize there was directions at the time. So I made up my own mosaic, thinking that that was the correct way. So it happened. It's not that big of a deal, but yeah.
Yeah, and honestly, yours turned out really awesome. So I'm actually glad that you ended up doing that, because I think that gives us another option for our assignment, right? So if teachers roll this out to their students and they want to give them the creative freedom to create it just like that, that works too, right? So you did an awesome job. Mandana, my next question is actually for you about your mosaic. Which shape on your mosaic is an equilateral triangle?
Well, actually, I know that very well because it's colored in white chalk. The equilateral triangle is the one that is colored in white chalk. So as you can see, it looks exactly like I'm about to draw. It looks like this. And you can also see that all these sides are the same length. They may not be right next to each other, but that doesn't mean that they're not the same length. They're always going to be the same length if it's an equilateral triangle. Now, if I had a triangle that looked something like this, which I'm drawing, this would not be an equilateral triangle because an equilateral triangle, remember, has to have all three sides the same length.
Yep.
Does it look like it has the same length to you?
No.
Another
So
thing you
that's
could
why
find
it's not an equilateral triangle.
Another thing you could find with an equilateral triangle is since all of the sides are the same, all of the angles at each point have to be the same on the triangle, which means if a triangle adds up to 180 degrees, if you break that down just by dividing it into 3, you get 60 degrees for every single angle on an equilateral triangle, always.
Yep, that was actually my next question, so I'm glad that you answered it. So we know that an equilateral triangle has all equal sides and all equal angles, so Karosh just explained it perfectly. If we don't have a protractor, or maybe our protractor is too small to measure an angle that big on a sidewalk mosaic, we can use our logic and we can use what we already know about the shape in order to answer that question. So if I were to ask Mandana that question, she'd be able to figure it out just fine if I said, what is the size of each angle of that triangle?
I would say 60 because it all has to add up to 180 in order to actually be an equilateral triangle. So that's why each side is 60 because it has to add up to 180.
Awesome. And now we can't do that with every shape. We can do it with the ones that we already know that the sides are exactly the same. Or for example, if we're taking a look at a square, we know that every single angle on it is what? What type of angle?
A right angle.
Nice. Awesome. All right. My next question is for Karosh. So let's go ahead and scroll back up to his for a second. Very nice. All right, Karosh, can you tell us where in your mosaic we could find a quadrilateral?
A quadrilateral triangle is any, not triangle, a quadrilateral shape is any shape that has 4 angles. So actually not a triangle. There are no triangles of my knowledge that are quadrilateral triangles because they have to have 4 corners. So like this one right here, it has 1, 2, 3, 4 corners. That makes it a quadrilateral triangle. Or just the entire square in general. It has 1, 2, 3, 4 corners. It's a quadrilateral triangle. Not triangle. I keep on saying quadrilateral triangle. It's just a quadrilateral.
That's okay. All right, so just to review that one, Karosh, I know you know it. A quadrilateral is any shape with 4 sides and 4 corners. You're exactly right. And triangles, they can't be quadrilaterals. You're
Yeah, no quadrilateral triangles.
Yeah, we just went over the fact that they only have 3 sides.
That's okay. Good. Nice work on the quadrilateral. You're exactly right. It has to have 4 sides and 4 corners. Next one's for Karosh as well. So there's one of the boxes, if you think of it as a quadrant, right? 1, 2, 3, 4. There's one that shows parallel lines. Which one shows parallel lines on your mosaic, Karosh?
This one right up here. So this one shows parallel lines because, actually 3 parallel lines, because these 3 are going in the same direction. If they went on forever, they would never touch. They'd stay right next to each other.
Absolutely. Nice work. Next one is for Mandana. Mandana, can you find a set of perpendicular lines?
So, a perpendicular line would be a line that is crossing, right?
Yep.
The shape of a 90-degree angle. So it would look like how I put my hands, like this. And so it has to be in a 90-degree angle. So it can't be looking something like that. Because this is an X, so it's not a 90-degree angle. So a way that you can actually remember that is if you remember that, I forget what it's called. What is it called?
I don't know.
I don't remember whatever. So just remember that it's a plus sign.
Exactly.
So you can always remember which one that is because you would know that it's a plus sign.
None.
It has to be a plus sign because plus signs have right angles.
Exactly. And you know what? When we were going over some of your math terms in your class, Mandana, one of the questions we came to was what letter of the alphabet has perpendicular lines? Do you remember one of the letters that has perpendicular lines?
Yes.
What is it?
I think I said H.
Yeah, right, because an H, if I were to draw an H up here, I see that it creates 90-degree angles here, 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 and here, right? So these lines, if they're to go on forever, are perpendicular, right? Very nice. That was an added question we weren't prepared for, but you did an awesome job on that, Mandana. I threw that one in.
I want to add, Munda pointed out the fact that an X can't be a perpendicular line, but in fact they can. They don't have to be a plus sign to be a perpendicular line. If you still have the 90-degree angles, if you turn it, it's still the same thing. It's still perpendicular lines.
Yep. So I think what Mandana was saying too was that if it was tilted, right? If there were
uneven X.
Yep.
But if it was a perfect X, then it would be a what's it called?
Yep, it would still be perpendicular.
Perpendicular. Yeah.
Yep, you're exactly right. I'm glad that you mentioned that because even though that it's like this, it still creates an X with a perfect 90-degree angle. So the important part of that definition is that it creates a 90-degree angle. Very good. All right, you guys did an awesome job on this. Tomorrow or maybe sometime tonight, you guys can fill it in and create whatever you want with your mosaics, create even more fun shapes in there, do a bunch of colors with your chalk, and we'll get to check that out maybe tomorrow. Danielle?
Did we do perimeter and area?
We didn't. Okay, so
I think we should go over that.
good. Yes, absolutely right.
All right, Karosh. So I followed Mandy's instructions on her sheet, and here it is. So if this were in inches and not feet, what is my perimeter and how did you find that of the whole big square? You're muted.
You're muted.
You're muted.
You're muted.
Okay, so what's it called? To find the perimeter on all of the ones we've made, if you followed the instructions, except for Munda's, because hers was a rectangle freestyle, which you could do, all of them will have a perimeter of 20 feet or 20 inches based on which size you made it, or 20 meters based on how big you went. Because all you got to do is you got to take every single side, so 1, 2, 3, 4, and add them up. So each of these are 5 inches, which gives you 20 inches in the end. And to find the area of the square, all you're going to do is just take the bottom and the side, so the x-axis and the y-axis, multiply those instead of add them, and to get the area, which is everything inside of the square, you get 25 because you multiplied these two by each other.
Yep. So the definition of area is just the length of your shape times the width of it, at least for the square.
Absolutely. Yes, I'm glad that you caught me on that. I forgot to ask about perimeter and area. You did a nice job explaining that, Karosh. All right, so like I said, you can color this, make it whatever you want now that you finished. I'm gonna link a worksheet below where you can answer a bunch of questions about your mosaic, whether that was one that you created on your own or if you followed our instructions exactly. Really excited to check in with you guys again tomorrow. And is there anything else that you guys want to add about the project?
Nope.
I would like to, I was checking if I was muted or not. So I would like to add, just if you're having trouble with any part of this project, remember it's supposed to be fun and learning combined together, not just learning. If you're learning but not having any fun, maybe you want to change one thing that you're doing because you want to have fun. This is something that we want you guys to have fun with. It's something to keep you guys busy in this time of year. So we're making this so you can have fun and education at the same time.
You're absolutely right. Good point, Mandana. All of our projects are meant to try to be a little bit fun, right? We want to make sure that you guys are both learning and having a good time. So create whatever you want after you've done the 8 steps, or create whatever you want. As long as you can answer those questions, then we're good to go, right? So
Cool.
good work on that. I hope that you guys have a good time and that you guys have fun with this project. And check out the links below for extra resources. We'll have a bunch of worksheets, things like that, that you can do that are all based on geometry. So we'll be seeing you all tomorrow, and bye.
Bye.
Bye.